topic is velocity analysis. Velocity analysis mainly can be found for the mechanisms by using different methods. One is analytical method and other one is graphical method. So analytical method requires to develop the equations, whereas in the graphical method we have different methods like relative velocity method and instantaneous center method. There are other methods also like time versus displacement curve method and rotating vector method. But these are important as per our syllabus: relative velocity and instantaneous center of velocity. Instantaneous center method. Suppose if I take relative velocity method, the importance of this one is when a point is rotating. That is, when you take a link which is rotating with omega, if I want to find the velocity of any point on the rotating link, it depends on what is the distance from that point to the center of rotation and the angular velocity with which it is rotating. So linear velocity of point P with respect to O is given by OP into omega. This is called the absolute linear velocity because this point O is fixed point. Suppose if I want the velocity of point P with respect to Q, which is also moving, then I can write this VPQ is given by distance of that PQ multiplied by omega. So that we can say linear velocity of any point on a rotating link is proportional to distance from that point of reference to the point considered. That is the magnitude. Coming to the direction, it always acts in a direction perpendicular to the position. So we say that the tangential velocity, because it will be taking tangential to the position. That's why it is called tangential velocity. So this is the velocity of a point on a rotating link. So what is this relative velocity method? Relative velocity method means, for example, when you want to analyze a 4-bar mechanism in which this link 1 is fixed and link 2, link 3 and link 4. Suppose I take this is point P, point Q, point R and point S. If I want to find velocity of point R with respect to P, it is given by, this is what is known as relative velocity method. Between point R and point P, there is a point Q which is also motion, under motion. So VRP, if I want velocity of point R with respect to P, it can be taken as velocity of R relative to Q plus velocity of Q with respect to P. This is what is known as relative velocity method. We can say that VRP is also VRS. This is equal to VQP plus VRQ. In the notation of vectors, SR is equal to PQ plus QR. So this is the equation. By using this equation, we can draw the velocity diagram. For example, the input link is 2, its angular velocity omega 2 is given. Say it is clockwise. Rotation also to be mentioned for angular velocity. And the position of this link is known to you. So we can find this PQ, velocity of Q with respect to Q, both magnitude and direction. Whereas for small qr, magnitude we don't know, but direction we know. Similarly for SR, magnitude we don't know, direction we know. So what we do is PQ vector is known to you because this is input link. So what you have to do is you should draw perpendicular to this capital PQ. You will get the small pq, which represents velocity of point Q, arrowhead point with respect to tail point P, which is taken perpendicular to capital PQ. Capital letters for position, small letters for velocities. Then small qr is always perpendicular to capital QR, because from this you understood that velocity of any point on the rotating link is always perpendicular to its position. So this is the QR, capital QR position. The small qr represents its velocity. To find this small qr, you should draw a line perpendicular to capital QR. Perpendicular to capital QR passing through this Q. So this is the small QR line, but we don't know the magnitude. So that's why just you draw any arbitrary length. This is perpendicular to capital QR. Then coming to small SR is perpendicular to capital SR. Because small p represents this position, small s is also same position here. This is called pole point, because for these 2 points velocity is 0. Then you have to draw perpendicular to capital SR passing through this small s to cut this at point R. Then you have to put this small SR is equal to small pq plus small qr. This is the velocity image of this 4-bar mechanism. This small SR represents velocity of point R with respect to S. It is also called absolute velocity of point R. If you take QR, this QR represents velocity of R relative to Q. This is what is known as relative velocity method. This is how we find the velocities of points on the 4 giant points. We can take small q and small velocity directly here. Suppose if I want at any intermediate point, say capital T, on this link 4, capital SR, you can locate small t proportional to this position of capital T. Suppose if capital T is midpoint of capital SR, small t also midpoint of small SR. That means the position of this is same proportional to velocity of that point also. This is how we can find this intermediate point. This is how you will be getting the velocity analysis by using relative velocity method.